What are control, status, and data registers in microcontrollers? Imagine you're trying to control a robot or a smart device. How does the microcontroller tell the hardware what to do, check what's happening, or send information? That's where registers come into play. They are tiny storage spots inside the microcontroller that help manage all these tasks. Think of them as the microcontroller's way of talking to its peripherals and itself. Control registers are like the switches and dials on a machine. They tell the microcontroller what to do with its peripherals. For example, if you want to turn on a motor or set a timer, you write specific bits into a control register. These bits act as commands, enabling or disabling features, setting modes, or starting actions. If you want to enable serial communication or set a pin as an input or output, you change bits in the control register accordingly. Status registers are more like the microcontroller's report cards. They tell you what's happening right now. These registers hold flags or bits that indicate events or conditions. For example, if a data transmission is finished, or if an input pin is high or low, the status register will have a bit set to show that. Software reads these bits to decide what to do next. If a bit shows a transmission is complete, the program can then send more data or process what was received. Data registers are the storage bins for actual information. When data is transferred between the microcontroller and peripherals, it is stored here. For example, if you receive a byte of data from a sensor or a serial port, it gets stored in a data register. When sending data, the microcontroller writes the byte into the data register, and it gets sent out. These registers act as buffers, holding data temporarily so the microcontroller can process or send it smoothly. From an electrical engineering point of view, these registers are built from flip-flops or latches. Each flip-flop stores one bit of information, either a 0 or a 1. These bits control hardware signals or reflected hardware conditions. For example, setting a bit to 1 might turn on an LED or enable a communication line. Clearing it to 0 might turn off a feature or indicate an error. In peripheral interfacing, these registers are essential. To communicate with a device like a UART or an SPI, software writes to control registers to set parameters like baud rate or data bits. It then checks the status register to see if data has been received or sent successfully. The data register holds the actual bytes being transferred. Manipulating these registers involves bitwise operations. You set bits to turn features on, clear bits to turn them off, or toggle bits to switch states. This precise control helps in programming embedded systems efficiently. In short, control registers set up and manage hardware functions. Status registers keep track of what's happening. Data registers hold the information being transferred. Together, they form the communication backbone between the microcontroller and its peripherals, making everything work smoothly.